Welcome to Season 3 of the podcast, Google's podcast about site reliability engineering and production software. I'm your host, Steve McGhee. This season, we're going to focus on designing and building software in SRE. Our guests come from a variety of roles, both inside and outside of Google. Happy listening, and remember, hope is not a strategy. Hey everyone, welcome back to another episode of the podcast, Google's podcast about SRE and production software. I'm your host, Steve McGhee.
And I'm Jordan Greenberg.
This season, we're focusing on software engineering in SRE, and today we have two guests to tell us a little bit about the development of a piece of software inside of Google. It's a system called Maglev, but we'll get to that. Our guests today are Cody Smith and Trisha Weir. Can you both introduce yourselves?
Yeah, I'm currently the CTO and co-founder of a startup called Camus Energy, but before that, I was at Google for more than 14 years from 2004.
Cool.
And my name is Trisha Weir. I am currently the manager of the Traffic Services Data Plane Infrastructure SRE Department. What that boils down to is Prod GFE, DDoS, and a number of other services all around the front end. I've been at Google for 21 years. Wow. I started as an infant, straight out of undergrad, much like Cody, and started in hardware ops and worked my way into SRE and really found my calling there. And I've been in various forms of production adjacent since then.
Fun fact, by the way, Trisha referred me to Google. I would not have worked at Google if it weren't for her.
Wow, this is so fun.
Cody and I have known each other since we were teenagers because we actually worked together at the student-run ISP at UC Berkeley. It turns out that if your idea of a fun student job is running an internet service provider, you might be an SRE.
Oh, wow.
That's awesome.
That is amazing.
Yeah, that was a great gig.
When I was in high school, I had a friend who ran a teenager ISP as well, and I thought it was the coolest thing ever. And I did not get a job, but I totally wanted a job there. I thought it was the coolest. And so began my descent into SRE as well.
There was a lot of physical work too.
Yeah. So today we're going to talk about rebuilding core systems with reliability in mind, namely this thing called Maglev, which is a piece of front-end infrastructure, and we'll talk about it more in a bit. But first, let's hear a little bit more about our guests. And we talked about it for a second just then, but what prepared you to become an SRE for either or both of you? You mentioned the ISP. Do you think that really did it? Was that the only thing that prepared you, or was there more?
I think the first part of the SRE, the ISP work, at least for me when I was really getting into it, was physical work. Like Cody and I, we showed up for the job and they would hand us these bales of network cable and we would crawl under the buildings, wiring them for Cat5. Some of it, I think, is this idea of the importance of getting the internet to the users really did sink in. Like working at that ISP, you cared about the users. You cared when their internet connections were down, they had a really bad day. And I think that kind of prepped me for the focus of reliability as an importance. What about you, Cody?
Yeah, I think I was a computer kid. I really did not go outside much. I was just always on the computer, playing video games growing up, and was very entranced by the web when it first came out. Was building websites in like 95.
Nice.
That's awesome.
Working at ResComp was a really nice complement to my education in Berkeley. It was like, in theory, a part-time job, but often like well over part-time, especially in the summer. We'd like be working 60, 80-hour weeks. And just a whole huge variety of different things. And that's kind of the life of an SRE. Like you don't necessarily work on the same problem for a long time in SRE. If you're making progress on the problem, you eventually solve it, you move on to the next biggest problem. And so
I think they call that like automating yourself out of a job. And it's like every SRE's wish to be able to do that for themselves.
But it's also being a generalist. And my favorite way to talk about generalists is to describe them as stem cells, because they're the type of person you can kind of drop in and they become whatever is needed, but they have the potential to be any number of different roles. I think for me, really what got me interested in SRE particularly was working at Google and being in hardware ops, because when you're out in a data center and something goes wrong, who's fixing it? Who are you talking to on the phone? It's the SREs. They were calm. They were competent. Even around campus, like I kind of describe them when they walked in formation. The wind blew in their hair and it bounced. Their mailing list was literally called the cool kids table. And you saw this group of people and you're like, I want to be one of them someday. Like they know they can just figure anything out. They drop into a situation they've never seen. They figure out what's going on. They're the cavalry. That's an appealing mission.
What a lovely image to have of like the SRE with the flowing hair. I mean, at Google, our SREs are like unicorns. So that's what I'm imagining now.
Walking in formation, coming in.
Yes.
Explosions
Absolutely.
behind them, just like a movie.
Yes, exactly. So since it took a while you got here, you saw these inspirational people who were at the cool kids table. They were SREs. Alias that now to what it was like when you were in search and traffic. How did these sort of like teams interact with each other? Who did what? Did they have as nice hair? All these good questions.
Yeah, I started when the teams were just starting to differentiate. So it was like production team back in the day, which then underwent like a cell division and turned into search SRE and traffic SRE. I had been working in a group called Cluster Ops and worked together in the Mustang War Room with a bunch of would soon be called SREs who, after the experience working together in the War Room, just picked up my desk and relocated it to their part of the office.
You've been selected.
And had a hard talk with my old manager. So in the early stages, there was a lot of kind of like work that was moving back and forth, and a lot of folks that were sort of straddling the two teams. Some people were like specializing pretty quickly, and others were kind of going back and forth. Like me, I had a lot of interest in the traffic stack personally, and so took on projects like Maglev over on that side, just probably because of my short attention span.
And to clarify for our listeners, Cody, you were on the web search SRE team, and then Trisha, you were on traffic team, which was about front-end infrastructure, load balancing, things like that. Is that correct?
Right. We were the first really infrastructure SRE team, and search was the first product SRE team. And I think GWIS followed pretty shortly thereafter.
Mm-hmm.
I think the teams were really close. Like we sat together, we ate lunch together, we hung out after work together. And a lot of that was really helpful because we kind of saw each other as one team. It wasn't like, oh, that's that team's problem. If it was their problem, it was our problem. Mm-hmm. It made for a really high trust situation, which I think we'll get into later, but it was really helpful. And there was a real cohesion. Like we all took our annual ski trip offsite together. We called it the single point of failure day because if there was like a big food poisoning incident, it would really hurt Google if everybody got sick at once. I think the interactions were really positive and really, really close ties.
That's awesome. So getting into the technical meat, the subject at hand, can you tell us, like, what do we mean by front-end infrastructure? Don't you just throw a bunch of Nginx's out there and call it a day? Or is it a little bit more than that? And then what is it that kind of happened? Like, what was the story? Like, we didn't want the thing anymore, so we're going to do something else. Like, what was the story of Maglev's beginning?
So when we say front-end infrastructure, the joke is it's load balancers all the way down. But it really kind of is. Everything that has to happen, if you type in news.google.com, everything that happens from you hitting enter on the keyboard to your query getting to a news backend or an ads backend or a Gmail backend, that's all really front-end infrastructure and front-end networking. It's massively complex. All of the things that allow us to have high reliability come with high risk of outage as well. We need to be able to load balance traffic across the globe. We do DNS-based load balancing. We need to be able to do failover between regions. We need to be able to absorb DDoS attacks, crypto term. There's a whole lot of things that are all happening behind the scenes.
Mm-hmm. And one thing about front-end infrastructure is that it's shared, right? Like it's not like everyone has their own stack, right? It's not like Maps has their own front-end infrastructure and then Gmail has their own, right?
Absolutely.
Cool. So then, yeah, what was the problem? Like, what did you guys face?
Yeah, we have right at the front of the stack, there's a thing called a network load balancer that's doing sort of IP, TCP level balancing of packets as they come in. And so it's keeping track of TCP connections and making sure that packets on that same connection always go to the same backend. From the network load balancer standpoint, the backend is the Google front end, GFE. And we were using a device provided by a vendor kind of in the realm of network hardware. Mm-hmm. It's the vendor's focus is on network hardware, and they were pretty expensive. I think they were something like $20,000 a box.
Oh, wow.
And then the support contracts went into the millions
I bet.
for all of the devices. Yeah.
That's where the real money is.
Yeah, and that 20K would get you a gigabit of throughput. When we started the project, it was like bidirectional, so it had to carry packets both inbound and outbound.
Getting on the DSR was my first project.
Yeah.
I remember going to the team picnic and there was a henna artist doing henna art, and we wrote DSR or die on my knuckles, like a knuckle tattoo.
Wow, I love that.
Yeah, that's DSR means direct server return. And so you can imagine a packet coming in through the network load balancer and going to a GFE. And then when it goes back out to the user, it just goes straight to them and not back through the load balancer. And so this saves you on egress bandwidth and sort of like removes a big constraint in your load balancer capacity.
So there must be a reason why there are so many comments about these load balancers. Did something happen?
A lot of things happened and they kept happening. There were some basic things like we needed features that the vendor would just say that's not a priority for us. We wanted to do GRE encapsulation to be able to allow us to do more advanced routing of the traffic. And the vendor would just say, we can't implement that on our devices anytime soon. The bigger issues were that, well, actually another growth issue is that they couldn't push very large configurations. And as we grew, our configurations got larger and larger and larger. But the biggest issue is they were deployed in an active-passive pairing. And this was our redundancy, right? If one of them had a problem, you failed over to the other one. But it wasn't a clean failure. The failover process caused these massive ARP storms. So you already have a failover happening, and then you have an ARP storm on the network because of that. And we brought all of these concerns to the vendor, and they really said, like, it's just not a priority.
Yeah, they were very focused on features. Like their other customers just really wanted lots and lots of like kind of layer 7 features that we didn't really care about. We were just bulk trying to move traffic in and out. And so we were kind of weird compared to the rest of their users.
Mm-hmm. And so the next thing was you just tried it.
Yeah, Eisenbud and I should explain actually a little bit of context. We had this mission control program where engineers would come over from sort of pure dev teams to join SRE for a rotation of 6 months. And then if that had worked out well, they might stay. So Eisenbud was one of the few folks in the team that had that, product development experience from before coming over. And she had reasonable confidence that we could do this. And the sort of like intuition about how to do things that I did not have because I'd come straight from undergrad into SRE basically. So with air cover from our manager, Jenna, who was, also consternated about challenges with this vendor, we started breaking down the problem into components and splitting them up. We made a list of, the load balancer is going to have these 7 subcomponents or something. And then she and I just took turns grabbing the next highest priority component from the list. Yeah. And that went actually much more quickly than we would have expected. I think of a network load balancer as a scarily complex thing, but I think it took 3 to 6 months between starting coding and getting the first live traffic onto the software stack.
That seems pretty fast.
That seems fast.
It was ludicrously fast. Like there was maybe 2 months between. I think you had a prototype within 2 or 3 months, if I remember right.
Wow.
Which we were running a little bit skunkworks, so that was important because you needed to. I think important context for this is we had just had another project on the team that had gone for a very long time and never successfully launched. It was an internal tool, and it, due to a number of scope creep issues, it never launched and was scrapped after a year. And so that was a challenge to credibility of software development at SRE. And so rather than starting this one with bold announcements that we were going to do another big project, that we were going to try this again, it was sort of underground skunkworks. And I think that really owes a lot to 2 things. One, to our manager, Jenna Hussain, who he saw these people and said, I believe that these people can get this thing done. And if they don't, it's on me. Mm-hmm. And then to the engineers, trusting the manager, because if you're an engineer and you work on a skunkworks project or you work on something that's pretty ambitious and it goes wrong, that's not great for your perf. It's not good for your promo route. It's a risk in your career. And so they needed to be able to trust that the manager would have their back if something did happen and would make it okay for them. So I think that was a big key.
I work with a lot of customers and kind of advise them on like what SRE even is and how to and stuff like this. The idea of just building a thing in skunkworks, I think, just doesn't come up in many enterprise environments. I think the high trust you're talking about is, and like just the skunkworks and like the ability to come up with something reasonably quickly is pretty awesome. So I have a question here, which maybe is not relevant, but it was basically like, how was SRE involved in the design and implementation of it? But I think what you're saying is, I mean, you and Eisenbud like just did it. Like you just did the design and implementation straight up. Like there wasn't a round of reviews and like an architect sign off and like a cost analysis spreadsheet or anything like that. Is that accurate?
No, we did write a design doc and it had diagrams of how we were going to handle these like esoteric things like packet fragmentation. And we had some novel stuff in the design, like consistent hashing function for backend selection, so that even under SYN flood attack, we could do reasonably accurate matching of incoming connections to backends. And I remember Urs actually commented on the design doc. He replied to the email thread and said, I see you are not planning to respond to ICMP requests over a certain rate limit, but people ping Google a lot and they really want to get those ICMP responses back. So please just answer as many of them as you can. It's important. Yeah.
Everyone's always pinging Google just to make sure the thing works. Yeah.
Yep, I do it too. I mean,
that's awesome.
There were some big shifts as it was going. You were talking about sort of SRE involvement. Some of it was, it was input from the broader SRE team on how this was going to go. At the time, we had a really strong distinction between control racks and production racks. Control racks in a data center they're fixed in place. They usually have rack-mounted machines. Things don't change in them very frequently. They're often specialized hardware devices. And
very special.
Yeah, our previous third-party hardware network load balancers were all racked into control racks. And when we first started looking into this, we knew we wanted it to run on commodity hardware, but we were thinking of having that, regular commodity hardware machine in the control rack. And there was a long tangent into how would this work? And I will say one of my own concerns coming from hardware ops, I'd been in hardware ops. I'd repaired machines in the data center. Anything in the control rack, that didn't come in through the system where you just got a queue of machines to fix. That was a special case. That they didn't always have the parts. It had to be a ticket. It was a one-off. We started exploring what it would take to get these to just be production machines in prod, in the cluster. So if you've got a Maglev running on a production machine and it fails, turn it up on the one next door, turn it up on the next free production machine. It's not as much of an issue of file a ticket, get someone to repair the hard drive on that machine and reinstall it. And so I would say that was wisdom of broader SRE. And I do think that was, broader SRE input into Maglev in particular.
In terms of timeline, this is also post-Borg, I believe, right? So it wasn't like, find a space in a spreadsheet for a machine. It was like, type button, hit enter, get machine, right? It was totally automated in that.
Yeah, I remember stealing a fair number of machines from Borg for Maglev provisioning when we were doing the cutover.
So if you don't mind me switching gears just a little bit, can you tell me about turnip, not the root vegetable, what that is and how it rolled out?
Yeah, the thing we were the most nervous about in the early days, we tried doing this thing. We took a piece of open source software, I think called Quagga, which was a BGP client, and wrapped it in our own sort of control layer. So it would interface with protocol buffers and stubby and so forth. So it would connect to the cluster router and establish a BGP session and say, for this VIP, I am the next hop. And the routers were then configured to allow that. And so we could start migrating VIP by VIP traffic over from the existing vendor device onto these Maglev servers. And we knew from doing load testing of them that the throughput was actually fairly limited. The Linux kernel was not great at that time at distributing a heavy network workload over multiple cores. And so these machines were pretty beefy, but like they were trying to do all the work on one core.
Right.
And so we had a limit in the like hundreds of thousands of packets per second per machine, like 200,000 or 300,000, whereas line rate for 64 byte packets would be like 1.5 million. So
yeah.
Oh, wow.
So just to clarify, when you're saying you went from VIP to VIP. So this is just a way to partition traffic. Like we don't have to get into all the details of what it is. So instead of taking all of google.com all at once, we take like a logical subset of it that represents map tiles or something like that, or, SSL traffic for email or something like that. And just say like, just this slice we're going to mess with today and see if it works. Is that about right?
Google Toolbar, if anybody remembers that, toolbar queries
yep.
were often one of our first things because it was an older product. It didn't get used as much. It was lower priority. And so we did have some VIPs that were designed for traffic that was more tolerant to risk.
Right.
I guess how I would phrase it.
That's important. Yeah. Being able to have something like that established up front helps a lot when you want to do an experiment like this. Because if your plan is like, we're just going to turn it off and turn it back on again and hope, not a great plan, right? Mm-hmm. Okay. So you rolled it out VIP by VIP. What next?
We started with the risky VIPs and got good results from that. Everything seemed like it was working fine. And we were doing some amount of redistribution because these machines weren't as fast as the vendor device. And so we couldn't just do a 1-for-1 cutover. Mm-hmm. But we just gradually worked our way up to the more sort of crown jewels VIPs that, web search and other super important products used in different clusters on different types of hardware. Cause like each hardware had potentially different weird constraints and like special kernel configurations and things like this. And just sort of have all the monitoring active during this cutover. The monitoring just hits the VIP. It doesn't actually know what's implementing the VIP. Mm-hmm. And so, those probes to the front end infrastructure would tell us if something had really gone off the rails.
That's awesome.
We had a lot of air miles to get. Like we would have schedules like, okay, we'll do this much and then we'll get air miles on it. We'll bake it for this many weeks. Then we'll do this much more. Mm-hmm. One of the things we always try to do is to get every type of diversity of traffic, of type of machine. Back then, it's less true now, but back then, certain regions of the world were much heavier on video traffic versus ads or search traffic. And so the traffic dynamics were different in different regions. You would have places with high packets per second, places with high queries per second. And we really tried to get a broad distribution of having air miles clusters or sort of test clusters all across the world.
Yeah, awesome. Heterogeneity or diversity in your workloads is really important when you're trying to satisfy something like this.
Yeah. And so I'm imagining that as you created these like environments to be able to try these things in, did you find any good bugs while you were testing this stuff out?
Yeah, there was one bug that I still think about probably far too often. It was in my code.
It haunts you?
Yeah. I wrote the kernel interface. So we use the same interface that TCP dump uses to get packets from the kernel, and the sort of packet parser code that goes together with it. And I was paranoid that there would be a bug in here somewhere. And so I wrote a fuzz tester that clamped on to the packet parser and literally ran a giant MapReduce with this code to process 1 trillion packets. Huge job. And it said no bugs. And I was ecstatic. But then the first time we got a packet that was larger than the snap length on the buffer that we had given to the kernel, it was the snap length and the packet length were different. And we were reading the wrong one in our code. Oh. And that's okay for most of the ring buffer. You just you read into the subsequent packet. But if you're right at the end of the ring buffer, you read out into unallocated memory and then use segmentation fault. And so we had done a turn up where some like local loopback traffic was 64 kilobyte MTU, and it was getting truncated in the buffer and crashed. And we figured out the problem right away. It was a very easy fix, but very embarrassing because it was like 5 lines of code before the fuzz tester plugged in.
Oh, wow.
So I get the sense that this wasn't Rust or Java or some sort of like fancy memory managing code language of modern times.
Yeah, it was C++.
Nice. Respect.
Yeah.
I think the other issue we started to run into as we were doing rollout was we started saturating the rack top switches. We'd considered the availability of bandwidth there as a concern, but it wasn't something that was built in as a concern to any of the systems that did auto replacement. And when we began being placed on racks that had other neighbors that were also high bandwidth users, we started having saturation problems. And so I remember having to work with, I think Isidore was the tool at the time. Cody might remember.
Mm-hmm. Yeah.
Isidore team to get and to write and implement a new constraint so that when it was allocating machines, it would check for that type of diversity as well.
So would you say that maybe it wasn't perfectly plannable and instead your teams had to adapt to emergent behavior that was resulting of this change that you made on a very complex system?
I think that that's fair. I do think that it's the sort of thing we think about now. It was a brave new world. And so we had given the sort of ambient knowledge of the industry at the time, we planned it decently well, but it always could have gone better.
Mm-hmm.
I mean, we're here today, right? I'm pretty sure Maglev is handling several hundreds of packets per nanosecond. I don't know, some sort of number. Okay. So
there's math involved.
With regards to like SREs who aren't at Google, right? That's what most of our listeners are on this podcast. Is this story too ambitious? Like, do you need to be the size of Google to do something like this? Not necessarily this exact task, right? But like this process of replacing a thing with software and like iterating and building it out and seeing if it works. Like, how would you advise folks out in the world to take this story? What should they learn from it?
I think there's always a balance to be struck with knowing, is this something I should build myself? Or can I make my use case fit existing tooling? Because you can move faster if you stand on the shoulders of giants. And so I think one thing to develop would be that sense of intuition about, is this something that no existing tooling is going to do? And do I need all these features? One thing Cody and I were talking about before we were on air today was the idea that there was a list of features that our previous hardware device could do. And Cody and Eisenbud, they just dropped a lot of them. They're like, we don't actually need that special feature. We don't need that special feature. What we do need is these particular set of features that nothing else on the market is giving. And so before starting a project like this, to decide if it's a good use of your time, I would say kind of build that intuition and that sort of awareness. Everybody wants to build something new and no one wants to do maintenance is a Kurt Vonnegut quote that I really like. People often want to build new things. Building new isn't always the answer, but having the judgment about when it is the right answer versus not is something that'll really help you.
Nice.
Yeah, I would say I think the time pressure was really useful in the context of the thing we needed to build. It didn't actually prove to be that complex. And a big part of that is the sort of brutality with which we kept things simple. The whole thing, not counting the BGP client, the code base was, I think, 2,000 lines when we launched.
Wow.
So it's just not that much code. And the time pressure of like, this is a skunkworks thing, we have to demonstrate a result before we get canceled was really useful because it made a lot of the decisions about, do we need to support this feature on launch day or not? Very simple. Like, if the answer can by any means be no, it should be no.
So what advice would you give today's, kids who are working at the ISPs, figuring out who they are, figuring out who they're going to be working with for a long time, for the next 20 years at some really huge company that may or may not even exist yet? What advice would you say to them about how they can, improve the world's internet and make it bigger, better, faster, stronger?
I think early in your career, trying to find roles that have a kind of big container around them. There's like a lot of different places you can go inside the role, and you're not going to be doing just like one thing over and over again.
Right.
But like lots of different things that all have to kind of work together is really great for making yourself into a stem cell that could go out and get a tech job in a bunch of different ladders at a big company, or become an entrepreneur and go do something you've never done before at a startup. It sets you up. It gives you that sort of breadth of skills so that you have more choices later in your career.
Nice.
So I am a big believer in the idea that SRE has an above average need for psychological safety. We are in the middle of an outage. We need to feel safe suggesting a very wild solution and knowing that your coworkers will not say, that's ridiculous. It would never work that way. I can't believe you didn't know that.
Right.
Because sometimes the wild idea is the thing that fixes it. That's true of SRE, but it's also true of anybody who's innovating. You need to be able to innovate, to have a wild idea, to take a chance and know that if you fall, your boss will catch you, to know and like the people around you. So much of at least my education was focused on you need to write code and you're going to write it all by yourself and you need to be heads down and get really good at this. But everything I've seen happen huge at Google has resulted from massive collaboration. And a lot of that comes down to being able to work with other people, being able to integrate their ideas, to respect them even when you disagree. So I would advise find people you enjoy working with, because if you're not enjoying your time, if you're not feeling safe, if you're not able to be your whole self around them, you're not going to bring your best ideas. You're not going to be able to get other people to work on your ideas, and you're not going to go as far. And it's just not as much fun. You don't have to be best buddies with everybody. You don't have to hang out on the weekend. There are plenty of people on that team who I adore, and we see each other, once a year now. We're not besties, but there's someone I think of as someone I trust and like and respect. And I think that aspect is really important.
That's awesome.
I have to say, it wasn't until I left SRE and Google that I learned the phrase "stay in your lane," and I thought it was pretty prescient that that wasn't a thing inside of Google, or inside of SRE at least. No one was told stay in your lane, because it's these lanes just there's so much stuff. Go ahead, and it just works better that way. Totally.
I would agree. All right. Well, thank you to both of our guests, Cody and Trisha. Cody, where can we find you on the internet?
The company I co-founded and work at now is called Camus Energy. We are camus.energy. And if you want to email me, I'm just cody@camus.energy.
Perfect. How about you, Trisha?
I am at Google, so you can email me, trisha@google.com, Trisha.
Perfect. Well, thank you, everybody, for making this episode of the podcast possible, and have an awesome day.
Thank you.
Cool. Thank you so much.
Bye.
You've been listening to Podcast, Google's podcast on site reliability engineering. Visit us on the web at sre.google, where you can find papers, workshops, videos, and more about SRE. This season's host is Steve McGhee, with contributions from Jordan Greenberg and Florian Rathgeber. The podcast is produced by Paul Guglielmino, Sunny Chow, and Salim Virji. The podcast theme is Telebot by Javi Beltran. Special thanks to MP English and Jen Petoff.